Download this code from codegive.com, link in the description below. Introduction to Machine Learning on FPGAs with hls4ml. High-level synthesis for machine learning, hls4ml, is an innovative framework designed to facilitate the deployment of machine learning models on FPGAs, field-programmable gate arrays. It converts trained neural network models into hardware implementations, allowing for high-speed inference with low latency and power consumption. This tutorial will cover the basics of hls4ml, provide an example of its usage, and demonstrate how to deploy a simple machine learning model on an FPGA. Prerequisites: 1. Basic knowledge of machine learning, familiarity with neural networks and their training. 2. FPGA basics, understanding of FPGAs and how they work. 3. Python, basic programming skills in Python. 4. Tools, you'll need access to an FPGA development environment, such as Xilinx Vivado and Vitis HLS, as well as Python libraries like TensorFlow or PyTorch. Setup: 1. Install hls4ml. You can install hls4ml using pip. 2. Install dependencies. hls4ml requires several libraries, including keras, TensorFlow, and NumPy. hls4ml workflow. The typical workflow for using hls4ml involves the following steps. 1. Train a machine learning model. Use a framework like keras or TensorFlow to train your model. 2. Convert the model. Utilize hls4ml to convert the trained model into a hardware description. 3. Generate RTL code. hls4ml generates a synthesizable C++ code that can be synthesized into an FPGA. 4. Synthesize and deploy. Use tools like vivado to compile the code and deploy it to the FPGA. Example: deploying a simple neural network. In this example, we will train a simple feed-forward neural network on the NIST dataset and use hls4ml to convert the model into a format suitable for FPGA deployment. Step 1. Training the model. Step 2. Convert the model with hls4ml. Step 3. Synthesize and deploy. 1. Open Xilinx Vivado, start a new project and include the generated HLS code. 2. Synthesize the design. Use vivado to synthesize the design and generate a bit stream. 3. Deploy the bit stream. Load the synthesized design onto the FPGA board. Conclusion: in this tutorial, we demonstrated how to train a simple neural network using keras and how to convert it into a hardware implementation using hls4ml. The process involves loading the trained model, configuring hls4ml settings, and generating synthesizable C++ code for FPGA deployment. Further reading: hls4ml documentation. The official documentation provides more in-depth information about advanced features. FPGA development. Explore more about FPGA programming and deployment using Xilinx or Intel tools. Machine learning. Learn more about various machine learning algorithms and their applications. Feel free to experiment with more complex models and configurations as you become more comfortable with the framework.